Okay, so today we're going to continue with the problem of change. And I'm just going to start over since last time we just introduced it in the last 3 minutes of the class. So, whoops. And that handout that you just picked up will come into play in a second. So last time we talked about how there was a philosopher named Heraclitus who held that everything is always new all the time. And the only way that seems to make any sense is if everything's flashing in and out of existence. So when things emerge into existence, they're new. Okay? So it probably sounds like a crazy idea. Just thought up by some philosopher. Until we discuss it a little further, you'll see it might have a little more to it than that. Okay? He held that if you step into a river, it's never the same river. Okay? Which seems to make a little bit of sense, actually. If you look at a river, it's always flowing with different eddies and so forth. So if you, it would seem hard to believe that it's the exact same state would ever replicate. Same particles and the same arrangements, creating the exact same stretch of river. There's too many little details. I guess probabilistically it could be the case that it could repeat perfectly, but it would seem like that's not likely. So also, we talked last time about this philosopher Heraclitus was interested in fire and lightning, which are two things that, when you look at them with the naked eye, it looks like they're the little flames of fire are flashing out of existence, and it looks like lightning is flashing out of existence like we saw last time. I don't know that much about fire and lightning, but probably that's not what's going on. I would definitely guess, but it looks like it from the naked eye. So that might be why Heraclitus may not have thought literally that they were flashing out of existence. He may have just been using those as examples of things that look like they're flashing out of existence. Okay? And of course he called that everything was ultimately made up of fire. The ultimate source of reality that composes everything is fire, which appears to be constantly new since it looks like it's flashing out of existence, the little flames and so forth. So this might sound absurd, but there's possibly something to this, as we'll see shortly. All right, let me skip down here. Now, this is where it gets a little more interesting, this page here. So before we discuss the scientific evidence for this flashing cartoon strip reality, remember last time we saw the cartoon strip, did we show that in here?
No.
Oh, we did? Okay. Yeah, I think that was the other section. Okay, the idea would be if so if there is a reality that's really involves everything flashing into existence all the time, it would look something like this, right? It would be all these instants are, somebody's just flipping through a book, all right? Kind of like this, okay? But it turns into, so each frame is completely still, like in a movie. But when you flip through them fast, it looks like motion to us, okay? Let me show you another one. Okay, so this one you can just see them flipping through it like that. So this is what we're looking at, possibly what reality is like, if the thesis is to be taken seriously. All right? So, pretty interesting. All right, so before we get into this much more, let's just outline the problem. It's called the problem of change. And it's called the problem of change for this reason right here. Just take any object, say this piece of paper. Okay, right now it's considered a complete piece of paper. Now it's changed. Okay? And it's changed again. Alright? So if you take any object O, say the piece of paper is the object, and it changes to a new state, we call it O star. So the unripped paper to the ripped paper or here I have such as when an apple changes from being red and fresh to being rotten, then O is different at O star. Right? So that O does not equal O star. Therefore, the first object O must cease to exist, and a new entity or object O star must come into existence. Okay? Now this can be also for all of reality. If reality R changes from R to R star, R is different from R star, R does not equal R star, and reality R must cease to exist and a new reality R star must come into existence. Alright, now take that handout that I just gave you. This I put into the notes right here last night. So I thought I would just give it to you. This explains it in a little more detail. So change of any sort appears to involve a mystery, as you just saw. Alright, Parmenides, another pre-Socratic philosopher that we haven't studied yet this semester, we might not get time to, argue that change cannot happen since it requires difference and nothing differs from itself. Okay? So you have to think about that sentence. Nothing can be different from itself. You have to think about that sentence, but that's what's going to be involved here. So the concept of change, let's spell it out further so you can see what this first sentence here means. The concept of change does involve paradox. It involves both sameness and difference. Okay, so if the paper is going to stay the same thing from when it's not ripped to it's ripped, it has to remain the same thing. But it's clearly not remaining the same thing. It's different. All right, because it was ripped. So it goes into a different state of existence. All right, so let's consider another example. An apple changes from being red and then brown as it ripens and starts to rot. The red apple must be the same as the brown, sorry, I just said apple, I changed my example, or else the apple does not change. Okay, but the red apple must also be different from the brown apple, or else the apple does not change. Okay, do you see how this is starting to reveal a paradox? So how can an entity be different from itself? How can a red thing be the same as a brown thing? How can a rotten apple be the same as an unrotten apple? Are they the same entities or not? If not, there is some point where the red apple ceases to exist and the brown one starts to exist. As if one ceases to exist and the other pops into existence. Okay, this is called the problem of change. We can't, to sum it up, nobody really knows how to explain how anything changes. Okay, if you try to explain how something changes, you run into these paradoxes. So we'll see this all semester. The simplest aspects of reality. What is the self? What is your mind? What is a material object? What is time? What is space? What is change? What is motion? All these things, if you try to describe them in the simplest terms, you plow right into a contradiction. Oh, something is the same and not the same. Sameness and difference. Okay? So let me repeat that. If we study the simplest aspects of reality, this has been known for over 2,000 years, 2,500 years in philosophy. They lead to contradictions. Okay, that leads to two options. One, our ability, you don't have to write this down because we'll cover this later, our ability to analyze reality as humans is extremely, just let's say erroneous. Even stronger than limited, good word though. Or the second option is the empirical, remember that word we use, the reality you can see, nature around you. The empirical reality you believe, you see, does not exist. Okay? Okay, so if our analysis is good, and we're finding that reality in the simplest terms involves contradiction, then if our reality involves contradiction, that we perceive involves contradiction, then it doesn't seem like it's realistic that it can exist. Okay, because nothing can exist by a contradiction. That doesn't describe anything. Somebody describe what a round square looks like. You can't do it. You can't even think about it. Okay, and so presumably such a thing doesn't exist. All right. So, or else it's the case that your reality, you're just seeing things incorrectly. That seems to be a weaker thesis because we'd have to be seeing things dramatically incorrectly in order for these contradictions to go away. I mean, reality would have to be completely different than we imagine it to be. Okay? One way it might be completely different is if everything is a cartoon strip reality. Everything is flashing in and out of existence. Okay, so if that, so the reality we think we see would actually be different than we think. It would be everything, instead of having smooth motion like this, that's not the case. It would be staccato motion. One famous Buddhist philosopher named Sherbutsky described this reality as a staccato reality, choppy reality, almost a vibrational reality. Okay? And it's needless to say our senses also would be incorrect in analyzing this reality. Alright, so are the apples, the red and the rotten, the non-rotten and the rotten apple, are they the same or not? Is the problem that we're, simple question we're asking, which puts us right into this. We don't know the answer. All we know is that our description falls into paradox, if not all-out contradiction. Okay? If they are, so if they're not the same entity, then at some point where the red apple ceases to exist, the brown one starts to exist. It's very simple. If the apples are not the same things, one goes out of existence, a new one comes into existence. That looks like this. If they are the same thing, then try to explain it. Yeah?
How are they going to be different things if it starts as the red apple? It doesn't just switch to brown. Slowly turns brown, so it's the same entity.
Yeah, you can take any two states. This is just a good question. This is just one way to illustrate it, red apple and brown apple. But it doesn't matter. You can have two moments of time right almost next to each other. And if one molecule is a little bit different in one apple than one state of the apple and the other state of the apple, then the same paradox will emerge. Any change. It doesn't have to be a dramatic change, a nice crisp apple to a rotten one. Any change at all is going to lead to this. Yeah?
Okay, so are you saying that in the time that it takes to change from one state to, from a regular apple to a rotten apple, each time it's a different apple? Is that
That's what this would appear to lead to. The problem of change appears to lead to that conclusion. It doesn't have to be red to rotten. It can just be, like I was saying to, what's your name again? Green, yeah. That's what I took my time. Any change. So presumably the apple will be flashing out of existence, say, trillions of times per second, or maybe infinite times per second.
Like every little change that happens.
Yeah.
Okay.
Every single time there's a change, this paradox will emerge. So another good question. Yeah.
Well, what would you say with time, or would you say light or time is flashing in our existence?
We're going to get to that in just a second. I'm skeptical that time exists. Personally, I think there's just events and the production of nature. There's a philosopher named Alfred North Whitehead, kind of an interesting name, but that's the philosophy that he endorsed as well. Because if you try to point to time, show me it. You can't do it. Nobody knows what it looks like. It's just something we think exists because there's this process of nature happening, this production of nature, all these events going on. So it appears that that's really what we mean by time, maybe. Yeah?
Yeah, I think you're just giving it a name, like time.
Yeah. Sure. Yeah, so it's saying something different than events.
Yeah.
If you don't, then you're right. You're just giving it a different name. Yeah.
I get the example with the apple, but what about water? When it just changes to ice. It's that's not like a molecular change. So would that be the same or no?
Yeah, same with.
And it's not changing though. It's just changing.
If you even have the positioning, they line up in a crystal structure with snowflake. Say that's the universe has had a change exist at some point. Say the little patch of ice right here, or water, and then forms a snowflake. There's been a change in rearranging or something going on. Yeah.
Well, I was just saying, isn't that kind of what Heraclitus was saying, is that everything is ever new? It's all
It seems like, the problem of change is something that's all over the place in philosophy. It's still discussed widely today. But in the ancient world, big philosophers, Heraclitus, Parmenides, Plato, Aristotle, these philosophers were extremely concerned with this. And so Heraclitus is an early place where we see it. He doesn't come out and say the problem of change. Don't know if it had that name. at that point, but he's describing things in the same way. Everything seems to be flickering, everything seems to be new, and so forth. Is that?
Yeah, that was basically, because that's kind of the same idea as what everything has to be new and flickering and
Yep. Yeah. Yeah. So it's. I mean, this isn't some trick I'm playing on you. This isn't the philosopher's little game. Well, let's word things in a strange way to trick everybody to think that the reality you see isn't there and everything's flickering and out of existence. No, this is very simple. Just simply tell me how one thing changes into another, and it can be anything, any change over any time, teeny time, huge time, and this sameness and difference paradox emerges. Okay, so it's not. It's very simple. Yeah.
In order for existence to actually exist, wouldn't there have to be a stop point in time? Isn't that like the whole point of existence, is that it has to come to a point where it's like, this exists, there's absolutely no doubt that this exists. I can say that that table exists, but because we're in a transfer of energy and time is endlessly going, it's not stopping, there's no transfer of energy, that table really doesn't exist unless I put it into my memory and say, at this point in time, that table existed. Everything else is just, I don't know.
Yeah. In general, if I hear what you're saying right, I agree that the table has its existence as you see it in your mind. It really is just a blob of chaotic energy, as we'll be discussing here in a second. Yeah.
Carrying on to what you were talking about with time, you know, how you said that you believe that it's just something that we use to measure terms of events. I seen, you know, something on like one of those how the universe works or something like that. The controversies.
On like Discovery Channel or something?
Yeah, yeah, it's like it's on the main content.
Okay.
But they were talking about like both sides of the argument, like, you know, whether time exists or not. And they say that like at certain altitudes, like if you would have
fly a plane real fast around the Earth, the clock changes.
You know, it would actually, you know, be recorded differently.
Yeah. That's just Einstein's relativity.
They also, you know, did some studies on like some mental illnesses, like schizophrenia. They said that like that stuff is like we have our own internal time clock, and that if our internal time clock is off, then we can experience, you know.
Yeah. Time. If you smoke a wad of marijuana, all of you are going to experience a little bit of time. Is going to feel like a huge amount of time. All of a sudden, you're going to say, "Wow, I've just been standing there for 10 seconds. I felt like 5 minutes or something." Or if you have an adrenaline rush, that can alter your experience of time. Or if you're sick, if you have a fever or something, you can look at the clock saying, "Wow, I didn't know that time passed that way. It felt differently." So yeah, it's very subjective. Those things seem to show it's very subjective. But last one, then we go on.
Wouldn't that just be our, understanding? Wouldn't that just be our
Sure.
perception of it, though?
Of course, we're locked in our little world of subjective information. And if we can't figure out what time is and can't record it correctly in our minds, then the only thing you've got to try to find some other way to describe it, to find out what it is, and that's going to be tough. So this is called the problem of change. And if the entity changes, it is no longer the original entity, it's a new entity. That's where Heraclitus seems to be talking from. So a bike, call it B, considered a single whole entity, is not the same when it's run over by a car. There, the bike is in a new state, called B star, the smashed state. So most humans want to say that B equals B star. But if you do, the paradox emerges. So that's like saying a bike equals a smashed bike. An unsmashed bike equals a smashed bike. Or that would be like saying the red apple is the brown apple. That clearly you can see you can very clearly see contradiction there. And especially if I change this to say the unsmashed bike. But that is, these seem to be, I'm trying to be, what I'd like to say is obviously these are contradictions, but I'm trying to be more open-minded than that and explore the issue with all of you. So I'm saying these seems to be, well, I don't say it. It appears that they're contradictions. It appears that this is the correct issue, but that means that the flickering reality emerges. Yeah?
Couldn't you just say unsmashed bike plus the process of smashing it equals smashed bike?
Well, but then you've got all those little states of its existence. When it first gets its first little bend, when the tire hits, you still have to change, and you have to describe bike B to B star. How are they the same entity? It doesn't matter. Like I was saying to Kareem, the amount of time is irrelevant. You can say the first instant of the universe to its last, if there is a last, or you can say two little time moments that are 1 trillionth of a second apart from each other, say.
So what you're saying is there is an absolute fundamental building block of time.
Oh, I'm not saying that. A lot of scientists think that now. They call it Planck length, or Planck
And
time
that's what
atom.
separates each chain.
Okay, there's two options. We're going to get to that shortly, but there's two options. Time atoms, if there was a basic building block of time, they either have a little duration, a little size to them, or they don't. They're just what's called an instant or a moment, no duration at all. So either way, whichever one of those is correct, scientists seem to hold the first one, this little Planck scale, 10 to the negative 43 seconds or something. I think that's incorrect for no reason we'll discuss later. Or there's the infinitesimal moment of time. Either one, you're going to get a still reality. The cartoon strip be one state of that apparently change thing that you see changing, but really it's just a set of still states. It's a very, it's almost a Zen-like issue. You know, motion is stillness. Okay? In Zen Buddhism, often reality is described in terms of contradiction and paradox. Just like Heraclitus does. Anybody heard of Zen koan? Yeah. It's often in Zen monasteries, what's called a Rinzai Zen monastery in Japan. Certain kind of Zen Buddhism. Instead of doing meditation like I'm going to teach you about later when we study Eastern philosophy, they will the Zen master will give the monk a riddle. Something like, what's the sound of one hand clapping? Or if there's a chicken that exists in a bottle that's fed food through the top, but then it grows to a little baby chicken, a chick, and then it grows to the size of the bottle. How do you get it out without breaking the bottle or hurting the chicken? So what a Zen monk will do is meditate on those for years in some cases, and it's supposed to lead to some kind of breakdown in their understanding of the empirical world, which leads them to understanding their nirvanic reality, which we discussed in the other class. Some sort of spiritual field that exists, that's omnipresent, that is apparently visible with your mind's eye and with certain Buddhist practices. So Heraclitus, this interestingly describes reality roughly with the same kinds of riddles and paradoxes. So anybody else have any questions before we go on? Let me,
This would be related.
Go ahead.
I was going to say this would be related to transportation, instant transportation and
teleportation?
teleportation.
Sure. I mean, if you can figure out how to bunch up, if you got the moment you depart and the moment you arrive, if you can get rid of all those instances in the middle and get those two to meet, then, that's the first thing that comes to my mind. You say that would be some kind of instantaneous travel. There is processes like that going on in nature. There's what's called quantum entanglement. Has anybody heard of that? There's something mysterious about reality that was discovered. It was first discovered by a prince, de Broglie, who, I guess he was bored in his palace or something, so he started studying physics in the early 1900s. He got so good at it that he won the Nobel Prize because he discovered something on paper which was later confirmed in the lab, and that's that some particles in reality, to put it as simply as possible, can interact with each other instantaneously. In other words, no time passes. So if you have, say, one particle here, call it A, another one here, call it B. It doesn't matter what the distance is, if it's light years, parsecs, or just an inch apart from each other, whatever. If you do something to this one, then something will happen to this particle at the exact same instant. So there's no time going from one to the other. So we'll talk about that later this semester, but that has a lot of philosophical issues to it. And yeah, some people want to link that to teleportation. Yeah, real fast.
You're saying, remember the brown apple and the red apple?
Yeah.
You're saying the molecules change, that's how he's saying it? The smashed bike, nothing's changed, it's just changing shape. So how could that be something different?
Well, I mean, like what you just said, nothing's changed, it's changing shape. So that's what you just said is a contradiction. Sorry?
Nothing like on the molecular basis changed.
Well, all molecular are changing.
Yeah, you're going to have some bonds and so forth that change because the metal reorients, so particles ultimately are going to reorient their positioning with one another. I mean, I like the idea you have. Think of jelly, just wound it up a little bit or something. What's really changed? But if its shape is changed, if that's an aspect of the thing, then there's a change. If you could somehow show that shape isn't an aspect of an entity, then you'd be onto something. But I don't know if that would work.
So it only works for things that have shape and things that don't have shape.
Yeah, the only things that don't have shape. Okay, that's where we're going next. The only things that I know of that don't have shape, possibly two things: quantum particles, if they have no size, basic building blocks of reality have no size, as we've discussed, or maybe your consciousness or your soul or something, if those exist as we think of. Now, here's what I want to discuss next. This might sound, a lot of you probably think this is just some kind of special trick. Oh, it can't be right, it's just philosophers playing tricks on us. Or somehow there's a way out of this, right? Well, it gets a little more interesting when you start studying the quantum particles, the basic building blocks of reality. Because what you were trying to describe is that the parts rearrange. Okay, but if none of the parts change, then the rearrangement, is that really a change? Like if I have a glass of water and I stir it up, it looks like the same glass. What really changed? So if you start trying to describe things changing in terms of parts, you can say, well, there was a number of states of the thing where the parts rearrange, but it's still overall the same entity. Some sort with a part rearrangement. So it's like half changed, half unchanged or something. You can start trying to reason in those sorts of ways. But this gets a little more interesting when you discuss things that don't have parts, such as certain quantum particles, certain basic building blocks like an electron or a quark. What we find is, which makes the problem change much more interesting, is those things appear to be doing exactly this flashing in and out of existence. All right? Now there's which is exactly what we would expect a partless thing to do, since you don't have the internal rearranging possibly you're trying to describe with the bite. Because like I said, what I think you were trying to say is the parts are the same, the shape is changed, but if the parts are the same, big deal, which is called the same thing. So partless things here are discussed by one of the main campus scientists in Ann Arbor, George Kane. He's a very famous physicist. Here's him describing in his book Supersymmetry that was published in 2010, page 19, by Perseus Publishing, Cambridge, England. Here's what he says. Nearly all particles, when he says particles, he's talking about basic building blocks of reality that we've already discussed. Nearly all particles are unstable and decay into others. The word decay has a technical meaning in physics. One particle disappears. Okay? Typically turning into two or three others. You have the conservation of energy. If one disappears, it has to somehow show up somewhere else. Students are always so concerned with the conservation of energy. We've always got lots of questions about that through semesters. But anyways, major difference between the way decay is used in physics and its use in everyday life or biology is that the particles that characterize the final state are not in any sense already in the decaying particle. Here we go. The initial particle really disappears. This isn't me, this is him. So if you don't like this, you can send him an email or something. He's just basically saying what we said about the problem of change, but he, instead of being a philosopher, happens to be a very famous scientist describing what science physicists simply see on their computer screens of what looks like machines are telling us quantum particles are doing. Okay, so the initial particle really disappears and the final particles appear. The photons that make up the light we see provide an example. The photons emitted from the light bulb when it's turned on are not particles that were in there, in the bulb, just waiting to come out. The as photons that enter our eyes are absorbed by molecules in our eyes and disappear. All particles can be created or absorbed in interactions with other particles. So the meat of this quote is right here. And there's another one. Let me get another one for you. Okay, hang on one second. Okay, here's Paul Davies. He's one of the most famous philosophers in the world, to my knowledge. Anybody heard of him? Ryan? No? Okay. When physicists began to study quantum theory of fields, they discovered that a vacuum was not all that appeared to be. Just empty space void of substance and activity. The source of the trickery can be traced to Heisenberg's second principle, which we're going to be studying very shortly, maybe even at the end of class today. As it relates to the behavior of energy, the law of conservation of energy can be suspended by quantum effects at a very short interval of time. During this brief duration, energy can be borrowed. Hang on a second. We gotta go to that. Go down here. Okay. Particles this way, produced in this way, are short-lived because the energy tied up in them has to be repaid. So particles are permitted to pop out of nowhere. See that right there? This is from his book Superforce. Sorry, it's not fully cited there, but it's a book called Superforce, 1984, pages 104 and 105. You might think, well, it's an old book, who cares? Well, no, this was discovered back by Niels Bohr. He's one of the first people to discover this kind of thing with electron orbitals, and electrons seeming to flick on and out of existence. So the age of the book doesn't matter. So particles are permitted to pop out of nowhere, enjoy a fleeting existence, fading again into oblivion. This is a physics book. It sounds more like poetry right there for a minute. This evanescent activity, now this is interesting, he uses that word. There's a book by the Buddha called the Dhammapada, where he describes reality as evanescent, like froth and bubbles coming and going. Okay? Remember I told you there's a shocking parallels between Buddhism and quantum basic building blocks. So anyways, we'll get that later. So those space can be, well, you've got the idea. This is down further in your notes. You can check that out later if you want. Let me get back up to where I was. Okay, so anybody have any questions? So all we've done so far is we've introduced you to the problem of change, which seems very simple, but probably most of you think it was just a problem in describing reality. But the problem of change gets a little more meat to it when you find out that it appears, unless some discoveries happen in the future where you find out that quantum particles really aren't popping out of existence, basic building blocks of reality really aren't enjoying this flickering state of existence. At the moment, this appears exactly what's going on. Now, we're going to see something below shortly when we study the uncertainty principle. It's a philosophical issue which is going to suggest that it's impossible for anything to do anything but flashing out of existence. Okay, so we're going to have more evidence piling up on this. Now, the problem of change, this is just one version of the problem of change. It has many different aspects to it and so forth, but we're just getting at one of them, which Heraclitus and Parmenides and several other philosophers were interested in. So, any questions at this point? I was kind of hurrying before, but if you have any questions, it's cool. Okay, good. I'll keep going then. So, imagine a tiny quantum particle following that Professor Kane quote with no parts, and thus it cannot change by an internal process of parts rearranging. If it changes in any way, the original state of this part of the basic building block ceases, and a new basic building block comes into existence. The key word there is new, which is what Heraclitus was so concerned with. Yeah?
Is he proposing that there's always change, that nothing ever remains the same?
Yep.
That's what it seems like.
That's what Heraclitus says. Parmenides, another philosopher, because of this says, okay, nothing changes, because it's impossible. So you can go either way. You can say everything perpetually changes, because if there's any sort of activity of any sort, it involves, which seems that everything is constantly I mean, even if you're out in the, if you're in a room, a still room, say a mile underground, you can't hear anything, and you're just sitting right there in the room, nothing's happening, you can still, there's breathing, there's air currents, there's little vibrations in the walls of, because that's what matter does, it vibrates around. So even if you can't perceive anything change, there's still change, which we're now finding out might be really flashing in and out of existence, if this is all correct. I'm not making a conclusion on any of this, I'm just saying, if you try to describe reality, this is exactly where you go. Yeah?
Well, how could airflow or something flash in and out of existence if we don't see it, or how could air flash in and out of existence?
Well, because if it's flowing, that would mean there's some kind of change process going on. If change process is going on, then you get to this mess right here. Okay? Anybody else? Okay. Now, interestingly, as I just implied a second ago, this is a problem discovered in the ancient world, ancient Greece, but it was also heavily discussed by Buddhists in 200 to 900 AD especially, but implied earlier than that, around 500 BCE, by Buddha in his book Dhammapada, which we think that, there's a book called Dhammapada we think was written by Buddha. Anyway, we'll get to that later. So not everyone has considered the problem of change to be a problem. I don't consider it's called a problem of change, but that's only if you don't like this splashing in this cartoon strip reality conclusion that the description of problem of change leads to. If you're comfortable with the cartoon strip reality, then there's no problem, which some philosophers have suggested. Okay, for example, there's two we're going to discuss here, David Hume, and was a Scottish philosopher from a couple hundred years ago, and Buddha. And some followers of Buddha afterwards, such as Dharma Kirti, who's a philosopher we'll study later this semester. So, for example, Buddhism of India, and also the famous philosopher David Hume, both side with something more like this cartoon strip reality. Okay? Here's an article, a clip from an article out of a journal called Philosophy East and West, which I read a lot. And here's what says. Both Hume and Buddha insist that it is wrong-headed to call something enduring, ever identical, self more real than our changing states. Both insist that the experiences themselves are spread upon no substance and upon no substantial self, but constitute a process in and of themselves. The Buddhist position is that there is no self-identical self. Okay, that's just saying that there's a cartoon strip reality. The perpetual flux in motion, what they mean by flux is flickering reality. That's how Buddhists, that word, it's called momentariness. That's what Buddhists call this cartoon strip in India. And sometimes it's translated as flux, which is of course not a good translation. That word used. So the abiding flow, but rather each of us is a numerically new actuality every moment. Okay? Another philosopher, Hartshorn, presents what he calls the Buddhist Whiteheadian doctrine. Oh, there's that philosopher Whitehead again. His name will come up a lot this semester. He's an interesting philosopher who wrote a book called The Concept of Nature, which we'll be studying a bit. So it's, we can skip down here. Well, I mean, you kind of have the idea. So there's other philosophers don't think this is really a problem. We'll study David Hume more later, and we'll see this issue there. But who says the cartoon strip reality is a problem? Okay? Big deal. So your senses don't report things accurately, and you don't see the staccato reality. You think you see a reality that has smooth motions and so forth. All this really means is your sense perception is very, very inaccurate. You see things the opposite of how they are with respect to this. Who cares? What's new? Your senses are completely fallible anyways. Okay? None of you can see, if you rip apart this chalkboard and look at its little building blocks as we've discussed, it is going to look like immaterial energy, whatever that means. Little pieces of little basic building blocks that have no size to them. Okay? So you can't see that. You see things exactly the opposite. You see a surface and a color. So for that's exactly the opposite way. So we talked about the leaf appearing to be green. All you need to do is put it under a microscope, and all of a sudden you find out that it doesn't look green. It's semi-invisible. So, and we'll have a zillion other examples this semester. So this appears to be, we've got philosophy on two parts of the world and contemporary science, both seeming to side with this staccato reality idea. And you're going to see something in a second here which drives it home even more. What this would mean is your senses are radically erroneous. Okay? Just another example. Does anybody have any questions? Yeah?
Okay, just with the concept of infinity, let's say we divide time infinite amount of times.
Okay.
Why would you still say that, let's say we did divide it infinite amount of times, it would still have the same properties as like time like we see today, like per second. Like, for example, like two parallel lines, they had never intersect, but it said that at infinity it does.
So this depends if the universe is curved or not, or space is curved. That's kind of...
No, it's the concept, I mean. It's not, not like in 3D or whatever. If you just draw two lines that are parallel, they say
it's
supposed to intersect.
Right.
So, like, why would you say that at infinite, like 0.0, infinity 1, that time would still apply with the same rules that we see, like, why can't you say, like, maybe at that one building block of time, that the same physics apply. The same physics we see right now.
Well, there's the answer to that, I think, if I hear what you're saying, is that there's different, humans don't know the whole picture. We know pieces. I mean, in those pieces we just know a little. For example, Isaac Newton developed some physics that describes just our ordinary world. How, if you throw something in the air, how it's motional. You can map things out in certain ways. And then Einstein came along and showed his work to be incomplete. But what he was doing is describing the mathematics of things on a huge scale, like the scale of the universe. Then quantum physicists came along studying basic building blocks, and they have a different way of looking at things. They're real small. All three of those systems aren't in agreement at all. So you need three different systems to try to get a grasp on things. Now, obviously the three systems don't contradict us. Humans only have parts of each picture. So you need different, until we get smarter or something, or learn more, have more time pass, we can develop our sciences better, we have to have different sciences. That's why we have biology versus chemistry. You know, really, it's just studying nature in both cases.
And you think that's possible, though? That we will get to that point?
Yeah.
I mean, can you say that we, as humans, we'll never get to the point we'll understand the concept of infinity, for example? It's just free function in our
To understand infinity, you have to have, if you're going to say if you have infinity, presumably there's infinite numbers of stuff. Infinite time moments, infinite grains of sand, or infinite people, or something.
An infinite past, like we can't, it's hard for us to concept, like,
Yeah,
to think about, like, what if time was just forever back, you know, that's hard to picture.
Yeah, you have to think of it as like a big block. You can't think of each moment, because to think about each moment, we have to have infinite thoughts applying, you know, denoting each moment. But we don't have infinite thoughts. Humans are real slow, serial thinkers, one thought after another, and it's just ridiculous.
So how are we able to make conclusions if we can't even understand, like, basic things like that?
We can. When we get to the postmodernism section, at the end of the class, you'll see the answer to postmodern sort of example or answer to that would be, well, all of our descriptions are partial. In other words, inaccurate. They always have been, and who knows any foreseeable time in the future when that'll change. It could be a million years, and we're still not sure what we're doing. So then we can't. There's nothing really important to do or say. Might as well just go to the course, become a poet. Huh?
So nothing really means anything right now.
That, with postmodernist perspective, there's two ways to approach things. You can approach it that way, and say, you know, nobody really understood things that well then, they don't now, so what's the point? Or you can say, well, there's some progress happening, you know, quantum physics helped us learn how to build HD TVs and nuclear bombs to go blow up Japanese people with and stuff like that. So, you know, I mean, there's some progress of we can manipulate nature. But like understanding the big picture, what's the self, what's God, what is matter, what is motion, we're not there, we're not even close.
Yeah.
I mean, a lot of people say there's no more big mysteries anymore. How about motion? There's one. I mean, it's very simple. I mean, well, the big mysteries we'll come to in this class are self, mind, motion, the soul if it exists, God if it exists, energy, time, space, the stuff that's all right here in this room. And that's all the final frontier, because nobody has a clue what it is or how to describe it. And it implies to me that humans maybe aren't meant for that. I mean, we're in the information age, right? But all the information is a bunch of crap. One of my favorite philosophers that we discussed last week, Baudrillard, Jean Baudrillard, a French postmodernist, he said the information age is just a disinformation age. Yeah, you got a lot of information, but does it really denote? Do you ever know what denote means? When you have a word assigned to the world, like some papers, okay, papers. They're seeing that word describes, and everybody's okay with that. But most of our language doesn't do that. Try to come up with a sentence that denotes the Big Bang. Good luck. That's what everybody in cosmology, the field of cosmology and physics is fighting over right now. You know, how to make our language actually describe stuff. So, yeah, so good questions. Anybody else? All right. Let's see. This is all good stuff, but I might... Yeah, here's more... well, let me just read through this. People usually imagine time to be a series of moments that are connected like a flow, like a river. But in this Humean Buddhist perspective we just discussed, there's no connection or contact between moments of time. There's the time atoms right there. Rather, there is only a witnessing of moments themselves, one after the other. So there's a lot of philosophers discuss this. Jean-Paul Sartre, here's a reference to him discussing it. There's a book where the early Buddhists are discussing it. Each instant of consciousness is like a new existence which does not arise out of a prior instance. Okay? That's from a book called Jean-Paul Sartre and Early Buddhism, written by this guy. Okay? It was published in India. Okay, so let's explore this in different terms quickly. Imagine if you okay, remember the difference between scientific atoms and philosophic atoms that we discussed? Here's the nucleus, which really is just a set of quarks, and then out here is this thing called a cloud, electron cloud, which is really just one or more electrons. So really what an atom looks like, a scientific atom looks like, is something like this. Now, I mean, there's basically no space. There's basically no material existence there. Just a bunch of energy points with no size that are suspended at a distance from one another. What keeps them at a distance? Well, the answer is more particles, but how does that work? How would any of them touch each other if they don't have a surface? How do things on a surface touch? Yeah.
The solution to that.
But one more thing, so that's what your question you just asked produces.
Yeah, like how gold would fall through the chair.
Everybody wants to know the answer to that. Yeah, sorry.
The solution to that, I'm not sure if this is true or not, but I heard that particles don't ever actually even touch each other.
Yeah, there's a quote from Kane, the same book, below in the notes, you'll see saying that.
The way that we think, I'm touching this bottle with my hand is what's stopping it from going through here. It's actually, the
electronic potential.
It's the electronic, the electromagnetic.
Yeah, if your finger is touching, say this is your fingertip, and here's the bottle of your health drink. Just kidding.
Yeah.
They say this is, it's actually just real small distance or something, is where it feels like it's touching you. What's actually happening is there's a stream of particles back and forth which feels like resistance that makes the two resist each other. They don't actually ever touch. That's the scientific version of it. Notice how science and philosophy are lining up here in the problem of change. Philosophy came along and said change doesn't make any sense, we don't describe it. Then science comes along and says, well, something we're discovering might support that. That concept of touching. There's another, remember we talked about the final frontier? Describe how one thing touches another. We're going to get to that later in these notes, and there's another one of those things where as soon as you describe it, you can't do it. So philosophy and science will again line up with respect to that. All right, so yeah, good point. So that reduces, like Kareem's question, that reduces to this idea of how do particles, what are they doing? Well, how do basic building blocks have any interaction with each other? Doesn't interaction require a surface? Like watch these two hands. I mean, they come together. The only way we know how to describe that is by surface contact. But if everything's made up out of basic building blocks that don't have any size, if that's indeed the case, what is it? It's an illusion? Anybody have any questions? Yeah.
Kind of back to like what Kareem said. So if
Kareem's the man today, huh?
yeah.
Go ahead.
So if we change form. Like every minute we breathe, we change form. So do we flesh in that?
When you say we, you mean your body or your
Like a
self?
person.
Well, that depends what a person is. A person, I mean,
As an entity yourself. Like you're saying you're sitting on the desk and the desk is flashing, but you're not falling through it. Are we flashing too? Because right now, like by our
sure, your body is at least. Any person's body is, if it looks like material stuff, and if there's any kind of change going on, that paradox emerges. So yeah, so you remember in the Matrix, Matrix people? I mean, they show this kind of happening in that, well, a little bit. The second Matrix movie, they show people kind of made out of electricity that seems to be flickering a little bit or something. But it's not clear if what a person is their body. If you, for example, if I take all of anybody's body and replace all the cells with machine cells, Darth Vader idea or something, well, I think he still has a central nervous system, or parts of it in the brain and head. But say we could replace everything, all the cells with machine parts, but you still have the same thoughts and feelings. You're going to say, feel a little different, but at the deepest sense, I still feel like me.
So physically we can,
Well, wait, so the point is if I take your thoughts and feelings away, so I mean, if I take your body away to keep thoughts and feelings, you'll still feel like you're you, but if I switch that, if I keep your body and take your thoughts and feelings away, then you're going to not have a self anymore. Or else you won't be able to identify with this body, it'll be somewhere else or something. So the point is that there's lots of discussion we'll have later in the semester about how it's not clear that the self is identical with the body. So if you read in the Bible, it says, you're created in God's image or something, that doesn't mean that God looks like a four-limbed hunk of meat or something. Because you might not be your body, you might be a soul or a consciousness or something. So it might be that you're some kind of energy entity. And that's what you're in the image. If there's a God that created you, and if you're in the image, that's what you're mimicking. Okay? Anybody else? All right. So if this is really how things are, as it seems may be the case, then how does M come into existence? M star, or O star, the second state. How does it come into existence? This is supposed to be, this is a big problem. Okay, so the problem of change, if you want to, it leads us to this, cartoon strip reality. So if you want to accept it, then there's another huge problem that just emerges. How does stuff seemingly come into existence out of nowhere? Remember Paul Davies saying, it seems that stuff just flashes into existence from oblivion. That's this world-famous scientist talking in those poetical terms. So it can't be caught, you can't have, this is kind of getting into some things we'll talk later in the semester. Usually we think of one moment causes another. Like if I go like that, and then you have a sound experience in your mind, cause, effect. This leads to that. The reason for your sound experience is the clap. Okay, but that's all gone with this flash in reality idea, because moments can't connect. You can't have one moment. This is the way the flash in reality looks. You got M star, M double star, M triple star, like that. So when one exists, the others don't. Okay, so how can you have two things connected when only one exists? Yeah?
This example is coming up in my head that seems to fit for me. It's more like we're watching a TV, and every moment there's a set of colors. The next moment, it refreshes. So each little pixel is different each moment.
Yeah, I see lights flashing out of that. Yeah, like 30 some times a second?
60.
Is it 60, and then you lower it to 20 or 30 times a second, then we get migraine headaches? So, go ahead, sorry.
I'm just saying that it's what I'm kind of picturing. It's like we're here, it seems connected, but it's still a unique instance every time.
Mm-hmm.
We're watching some film, but every single pixel is unique.
Yeah. I don't know if that is a product of the way machines are created, or of cartoon strip reality, but yeah, good illustration though. Yeah, right.
Assuming that atoms or the quantum atoms or philosophical atoms which are being in existence have some sort of duration, would it make sense then that...
They may. That's one thing that some seem to have this teeny, except neutrons would seem to even have a long duration, some seem to have a teeny duration. Now I don't know what that would do to this.
But when is the problem?
It would still look more like this than it does continuous motion.
Yeah. So when is the solution to the inability to interact between these instances of flashing and this is to be solved by the fact that they're not doing it all at the exact same time?
No, because you've always got one instance of reality. All the particles exist.
So you're saying that it's much more like the refreshing of...
To have contact, you have to have two things flowing through time and going, but if nothing's flowing, then nothing's contacting. We'll get to that later, yeah. Way in the back.
So, like with what you just said, like reality can't connect with each other, like in those instances. Doesn't that like go against like the theory of gravity, action, reaction, and all those?
No, because what is gravity?
Yeah, I was about to ask that.
Nobody really knows exactly, but it appears it comes from a particle called the graviton. Okay, don't worry about the word, it's just a name for a basic building block. Okay? And so if you have the sun, say you have the sun and the earth here, they have gravitational attraction between them. All that is, what is this thing here? Well, magnify it as much as you can. It's just a stream of basic building blocks flowing back and forth that are disconnected. So the same problem just emerges again. I know we're used to thinking if you take intro physics or something, they'll tell you, we'll talk about Faraday and all those guys, they'll say, the lines of force of the, look like this. We'll draw an electric field and say lines get closer, it's more intense, and then further apart. I mean, that's all fiction. None of that exists. And those fields are made out of basic building blocks that appear to have no size. So it's very, 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 very mysterious how reality is at the little teeny level. Make sense? Kind of? I mean, not make sense, but answer the question.
What I'm trying to get at is, okay, if like, I'm floating, and then gravity pulls me down. Like, I went from right here to right here, you get what I'm trying to say?
Yeah, like this, see?
Yeah, exactly, so like, when gravity caused my like, molecules and all that to just shift down, so, so they does connect though.
Well, what do you mean by connect?
I mean,
What is that? We talked about denote. What does that denote? Or what's denoted by that? That is a good question because you're getting to the fundamental issue. If gravity really looks like a bunch of disconnected particles, then if that's true, either that's wrong, the particles, there really is some continuous stream and we just don't see it, or if the particles are disconnected, then this word doesn't describe, you know. So it appears that that's not what's going on. Yeah.
does this theory say that at one moment there could be M, and then next moment there could also be M? Or does it say that...
Oh, like the same entity emerging? Yeah, that's, you'd have to have no changes of any sort. If it's possible, that there's a state that can just recur. No changes at all. Or say you have some amount of time, say you've got, each of these is a moment of time that, so the moment 1, 2, 3, 4, 5, 10 quadrillion, trillion, zillion, whatever all these are. Well, let's say this one, moment 3, somehow exactly matches that one. Call this one Google. It's spelled, the number Google is spelled differently. It's spelled in Google.com. Because Google's a number. How do you know that? Yeah. So what if they repeat? They're asking the same question a different way. It would seem that there's some probability that it would happen. If everything's just made of particles, then if you have enough time and all the particles are flickering around, well, why not have at one time way back, they all show up in this arrangement and state, and then 60 trillion zillion years later they happen to appear in the same exact state. It seems like there's a probability that could happen. So does that mean, say that instant is right now, and then it repeats in Googleplex quadrillion years, which is a long time from now, if there's even a time that exists. I mean, would it then be the case that you and I are both sitting here going and doing all this stuff? Maybe, yeah, right.
Or
wait, sorry. You're
yeah, I was going to say, so this indicates that there's no such thing as cause and effect.
This would be, cause and effect, that's a really good question. Cause and effect is just simply a pattern we observe. Like if I throw this chalk up, which I'm going to do in a second, how many of you think it'll come back down? Watch. It did it again. It does it every time it seems. It never, keeps falling, up, goes through the ceiling and out into space or something unless you can throw it really, really hard. So all that happens is we see one instant throwing and then another one catching, up, down. So all we know what causation is just a set of perceptions. But what's really happening in reality is another question altogether. That's another one of the fundamental frontiers. Final frontiers. Try to describe causation. You'll see. We're almost there now, actually. So both the flashing cartoon reality and, if this is wrong, regular reality that we usually think exists, enduring, both of those have causation because it's just a rhythm of events. It's just very different.
They're independent of each other. How is there a rhythm? How are they?
Because we can see one event follow another. In this reality, we don't know how it works. In the other reality, we don't either.
That reality.
Sorry?
I was asking about that reality.
Oh,
how it's called
the rhythm will still be observed. But we'd have no idea how, where all the new moments come from. Does God create them? That's an Islamic philosophy. There's a philosophy we're going to talk about pretty quick. Next week, I think we'll start called occasionalism. And that's the idea that, we have no clue where all these moments are coming from, so they must be created by something outside of nature. Well, what has the power to create everything at every instant that exists outside of nature but creates all of nature? That's synonymous with what we usually call a creator God. In classical Islamic philosophy, that was the standard position held. And you'll see next week it's quite sophisticated. So I've got 4 minutes left. Let me, oh, did you have something fast?
No.
Okay, let me keep going here. So that big mystery, how does the M star emerge? Because it doesn't seem it can come from M. So if M star can't come from M, does M star come from nothing? That's called creation ex nihilo, which is in your Bible, ye Christians in the audience. Because doesn't it say God created everything from nothing in places in the Bible? It doesn't say God created everything from his existence. So everything, one form of energy was manipulated in another. No, it says God created everything from the void, or nothing, or something. So if you think it's a weird idea, well, it's actually very close to home for many of you. So philosophers all the way back to the ancient Greeks strongly resisted any sort of creation ex nihilo, and that's still the case today, as do most philosophers today. Since it seems utterly impossible, well, is it? I mean, that's exactly what cartoon strip reality leads to. Okay, so if that's the case, then the creation ex nihilo is not an option. Then we have to entertain the idea that M star is caused by, not by M, or any other item. Because you know how we usually think one moment is the reason for another, so one moment causes another? No, in the flashing reality, you have to say something completely different. If you've got one object, then it ceases to exist, and then a moment later you have the next object, M star. It wasn't caused by M, okay? Something else caused it, which is actually, forget that, we just talked about it, because this is this Islamic issue right here. Something else can cause all the particles to come into existence. That is defined as God, as we just said. As, you might say right here, giving reference to which Islamic philosophy. Well, it doesn't, okay. But there's a section on that coming up here. Does anybody have any questions? Man, I just read the end of the section. I hate doing that. Well, there's only 1 minute left now. All right, so it looks like your quiz will be over. Anything in this long problem with change section here?
Is there a page on the bottom? Or the
And the handout, sorry.
Is there a page, number? I forgot which page we're on. The way it's on the bottom, 17?
Oh, no, it's just, I don't know, I think my page number is different here. It's just this section here, Heraclitus Part 2, the problem of change, flashing fire reality.
Okay.
It's that section.
That's the section we got started?
Yep, we just did the whole thing right here.
You mentioned that because we can't figure out truth is unknowable and giver
They don't think they do, but they are.
You're also philosophy of religion class, perhaps?
No, intro. But a lot of religion comes up.
Oh, okay. Intro to philosophy?
Yeah.
Oh, okay.
Oh, yeah.
What are you doing? And it says, hey, I'm done. We might as well be using the dreams that make us happy rather than what time in the morning? Tomorrow? Oh, yeah. 10. So it's like that idea that everything is bullshit. The motto is live by the law, strong, happy, and existence is a big part of it. Yeah, it's hilarious. It's extra relaxed. Bullshit.
No, that's extra relaxed.
Look at your face.
You say the rim paper is the rim paper, that's the problem.
Or maybe you know
I can say that the rim paper is usually
the idea of to be relaxed. Did you practice and introduce the idea exam? Keep doing it over and over and over and over and over and over again.
It's a red apple.
That would be incredibly dangerous.
How can I say it?
Not the whole. No.